Hello and welcome to series. So we are learning about how to deploy the Python application in a production ready environment, in a production ready setup. Whenever we talk about production setup, the first thing that should come into our mind is VPC and how to configure subnets, routing, and all of these things. Basically security related stuff as far as our VPC is concerned. So we will learn in this video about how to create a VPC and all of its components by the help of Terraform to understand the basic things about VPC so that when we write the code of Terraform, we can understand actually what's happening behind the scene. We will create a VPC by console, and then in the third step, we'll write the code to create VPC with the help of Terraform code. So let's get started. So let's talk about the VPC. So far, we have seen how to start with Terraform and how to initialize the Bastion host. Now it's time to understand what is VPC and why we require it. So VPC is virtual private cloud. It, let's say, all of your resources, resource A, resource B, resource C, resource D, it keeps them isolated. So this is the idea behind using VPC. If I tell you in one sentence, VPC and everything regarding this VPC and components is all about controlling the access. How you control the access of various resources, how they communicate with outer world, how they communicate with each other. This is all about the VPC, that is virtual private cloud. So let's go deeper into it. Okay. So let's assume this is your whole AWS setup. Okay. This is your AWS. Somewhere inside you have your Django application here, your Python code or your Java code here, and this is one of the subnet. We'll talk about what is subnet in detail, but this whole thing is inside the VPC, but it is in your VPC. This is your VPC. Okay, so this is isolated environment. Even though AWS makes sure that let's say there are 10 15 customers, C1, C2, C3, the resources of these customers don't interact with each other, but these customer can also create internal isolation by the help of VPC. So let's say this customer 1 have VPC 1, VPC 2, VPC 3. So this is isolated from this. So this helps like dev environment have separate resource. Dev environment will have separate EC2, separate Jenkins, that we will do. Okay. Similarly, V2 environment, that is, let's say this is staging environment and this is your prod environment. So all of these environments have their resources in their respective VPC, and that's the idea of VPC, right? Even though the customers can't see each other's resources, now the VPC can't see each other resource, and they can't communicate until unless you have the VPC peering. Okay, this is itself another concept. We'll look into it in some other video, but they can't communicate with each other. Okay, until unless we peer them with each other. All right. Now, so we understand what is VPC. VPC is nothing but isolated environment grouping inside your AWS account. Okay, so VPC have some range, IP range, like I can give it from this range to this range. Now let's say here we can have let's assume 100 IP address. We'll talk about this thing, but let's assume we can have 100 IP address, and you want to divide these IP in half 50-50. That 50 IP goes to some one part, let's say A part, and other 50 goes to B part. There you introduce the concept of subnet. Okay, so these two are subnet are not like there is some two type of subnet, public and private. These are how we give them access. If we deny direct access to some subnet, it automatically becomes private subnet. This is just a naming convention. Okay, so subnet is range of IP address, how you are allowing the range of IP address to be. So like this subnet have from 10.0.1.0, this is 10.0.2.0. Okay, so you can say subnet is a range of IP address in your VPC. So subnet must reside in single availability zone. Now what is availability zone? So there are regions in AWS, as you know, like US, West 2 that we are using is Oregon, AP South 1 is Mumbai, right? So these are the regions. In region, we have multiple availability zones. So let's say we have two AZ1, AZ2, and inside availability zone, similarly we have the VPC concept. Like in the VPC, we have public subnet, private subnet, or we can have multiple public subnet and multiple private subnet. So for example, this is our region. So let's assume this is our AP South 1, that is Mumbai region. Inside it, we have availability zone. It is big, okay? It is not only this part. Similarly, we have another availability zone B, and but in region we have somewhere our VPC. This is our VPC, and inside this we have private subnet, public subnet. Similarly, we have public subnet, private subnet. So we have PSA and PSB in B in availability zone A, like this. Okay. So what we can understand is that in our region we have availability zone, and we can have VPC also spanning across availability zone. But the point is private subnet can't span across the availability zone. Okay. How you create the VPC? As you have seen, if you have to create the VPC, you have to, or any resource, you have to start with the resource tag. Okay. Then this is fix, comes from the docs. This is the name that you want to give. This is the resource because you want to create something. Okay. Just like if you want to create something in REST, you hit the post API. Similarly, you use resource in the Terraform. Okay. Then these are our configuration CIDR block. Then we want to enable the DNS and hostname, these things, and there you go, we have the VPC right setup. But then we have to set up the subnets, then we have to set up the routes, etc. Then that we will talk. So you understand what is VPC, you understand what is subnet. Subnet is nothing but set of ranges, okay, inside a VPC. If this VPC have 1000 IP address, we assign like a 500 to one subnet, 500 to other subnet, just having a logical isolation, or you can say logical separation, not isolation. How we control the access? As I told you, everything in VPC is about controlling the access. How you control the access? One is by security group. You understand that when we go to our EC2, right, there we have the security group concept. We say like, this is my instance, this is my EC2 instance, and then we allow SSH is allowed, host 22, from where? From everywhere, let's say. Okay, VPN is not configured yet. You say HTTP S is allowed, from where? From everywhere. When we write 0.0.0.0, it's like from everywhere. Okay, from whole internet it is allowed. We allow HTTPS. Let's say a simple website will allow these two, or we can deny HTTP and directly only allow HTTPS. So if you go to EC2 console, so let's say this is my instance. Here we have the security. Let's create a security group, or let's say this is one of the security group. So as you can see here, we have the inbound rule and we have the outbound rule. This is important. So inbound rule means how the traffic will come in our server from the internet or from outside, not only internet, from outside the instance. Okay, this is at the instance level. So all the income, so this is my EC2, right? So this traffic is inbound and outgoing traffic is outbound in security group. So security group is set on the instance level. Okay, so in this case we are saying that we are allowing all type of traffic from this source. Okay, we'll talk about like what will happen if we allow security group in the source. So it is like if let's say this security group is from some other instance, some other EC2. So from that EC2 we are allowing every traffic coming. Okay, but let's create a new EC2 instance, new security group. So when we create a new, so we have to give the name. Then we say inbound traffic, we want to add the rule. So we can, you can see like we can give MySQL 3306 port. Okay, we can give HTTP 80 port. So all the 80 port request will be allowed. Then outbound means how this will access other things. So we can allow all, and this 00 ins from what source we want to allow. Like I want to allow HTTP from only certain IP address. Let's say this is my Jenkins, so I don't want to give Jenkins access to everybody else. Okay, I want to give access to some certain sort of people. So that's why we can restrict that in this source. If we do this, so you can see everywhere is coming. If I do custom and I enter a IP, so only this IP can use, right? So this is the idea. Now now we understand what is security group. NACL is network access control list. They are on subnet level. Now we are going ahead. Okay, how subnet will communicate with each other, that is with the help of NACL. Okay, network access, just like security group are on the instance like this. Let's say this is our EC2 instance, so this is security group will talk, and this NACL will talk to subnet. Important thing, that route table. So route table is like this. Okay, we'll create this one. So route table means how we route the traffic. So if the traffic is from this, we say the target is local. If the traffic is from this, we say the target is internet gateway. Internet gateway allows our resources to talk to internet. Okay, so if the traffic is going to this port, we pass it to internet gateway. If the host or if the IP address that we want to communicate within our VPC is like this, so we say it is local, please allow local communication. So our internal resources like this can talk with each other. Okay, because we have route tables configured here. We will see how all of these things are, but I want to give you a rough idea, then we will create the resources. Assignment of public IP address can be configured. So these are the point, like how you can control the access. You can control the access by the security group. You can control the access by NACL. You can control the access by route table. You can control the access by denying public IP will not be there. For example, you can say, I don't want to give public IP at all. So what will happen if our public IP is not there, like it is in the case of private subnet, they don't have public IP. The resources here don't have public IP, so then they can't communicate to internet directly. They need net gateway to communicate. Okay, this is network address translator. So they translate their internal, that is private IP, to public IP so that they can communicate, but otherwise they can't communicate. Okay, so this is kind of like auto assign IP address. You can enable or disable the button. Okay, then the last thing is private subnet. Private subnet is we don't allow outbound traffic. Okay, to allow the outbound traffic, we need network access translation. So this is how we can control the access in the VPC. So this is an example of how VPC is in AWS. So in for example, we have, let's say, example VPC. I have taken this from AWS doc. So example VPC, this is my CIDR block 10.0.0.16. Okay, 16, what this is specify, we'll talk our introduction to CIDR block. But this is our VPC, the subnets. So let's say we are in US East region. So we have two US East 2A, US 2 East 2B, and we have subnet, that is one is public subnet and a private subnet in this US East 2A, and we have public subnet and private subnet in US East 2B. Okay, so US East 2A and US East 2B have public and private respectively. Now route tables are there. So one is for the private one, private two, and one is common for the both publics, and they are all allowing to internet gateway, and this is gateway endpoint. Okay, so this is how all of the VPC resources are configured. So I think now you understand what is VPC, you understand what is subnet. You might be having some confusion about route table, internet gateway, and net gateway. So let's break these things, and then we will go to creation of the resources. So let's say this is your whole VPC. Okay, this is my VPC. I have a private subnet and a this is my public subnet, and this is my private subnet. What will happen is our database will reside in the private subnet. So this is my DB. Okay, and my Django app code, application, Python code or Java code, whatever, will also reside in the private subnet, because we don't want that to share with the world, but we want people to access these. So we have load balancer in the public subnet. Okay, so load balancer can communicate with the private. We have the Bayesian host also. okay, that we just created. So bastion host can go and SSH into the our Django code, SSH into the database, but directly people can't access it. We don't have such configurations, such routes allowed in this subnet. So such routes are not part in the private subnet. Okay, so what subnet is just a subnet. It is not private or public. We create it by the help of behavior. Just like a person is not good or bad, it becomes by the help of its behavior. Similarly, if it don't have any route, it will become private. If it have route to come from the outer world, so it will become the public. Okay, so our private subnet, the outbound request can't come. Outbound can't come. This is the important. I can't directly SSH into the database. I can directly connect to the database. This is important. Okay, because also they don't have a public IP. How I will able to connect? They only have the private IP. Okay, so private IP. What are the private IP? These are the private IP. Private IP helps us to communicate within the VPC. Okay, you might be having confusion like what is public, what is private IP. So within VPC, we can communicate with the help of private IP. So private IP like this 10.0.0.1, 192.168 from this to this. These are reserved private IP and they can't be taken in public. So you will never find a public IP like this. Okay, you will never find a public IP from this to this, from this to this, from this to this. For example, when we run our local system, we have this type of thing in our router, etc. Okay, so let's say giving a scenario. I my private subnet have a MySQL database whose public IP I don't know because that is in the private subnet. We not assigned it, but whose host is like this. Okay, so in our Django code we will write please connect to this. Okay, this will become my host because Django is in also in private subnet, so they can talk to each other. They can talk to each other because in the route table we have assigned this. How we assigned? Because all the CIDR when we say /16, these two are variable, so all of these things will come. Okay, so if an address have these type of things, pass it to local. We have assigned it. So local means they can communicate within each other. So private or our bastion host can also connect to this because they are in the same VPC. So this is the idea behind VPC and using the route table. Now let's talk about the how public subnet can or the public subnet can go to the internet gateway. So what happens is here we have the internet gateway. Internet gateway can accept the traffic from the internet. So let's say when you hit google.com, they might be having their internet gateway. Internet gateway will route the request to the load balancer. Load balancer is the public subnet that will traffic route to the Django or Python code, okay, or whatever the code they have. So this is internet gateway allow access of the internet to the resources. Now, what happens if our private subnet have to communicate to the outer world? Okay, because they don't have the public IP, how they will communicate? They will communicate with the help of net gateway. So this is whole idea of internet gateway, net gateway, route table, VPC, subnet, etc. Now, last thing that I want to tell you is CIDR block. So you understand that subnet is range of IP address only. Okay, nothing but range of IP address. CIDR block. So IP address actually. Let's talk about IP address first. So IP address is like this. Okay, it have if you break these in binary, 172 will become this, 16 will become this, 0 0 or 0. So how do 2 per 0, 2 to the power 1, 2, 2, 2 to the power 3, 2 to the power 4, 16. Okay, so like this you can turn it into the binary code. So these are 32 bits. So there are 2 to the power 32 possibilities, that is 4 into 10 to the power 9, something like these possibilities are there. Okay, so this is our IP range, and we have a network prefix. If we go to CIDR just with classless internet domain routing. Classless because there are two type of things basically. One is class B. There are basically 4 or 5 classes like class A, class B, class C, class D, and we have divided them. and other is this classless domain routing. This is much better than class with class. Okay, and so these two things, and in this we have routing table simplified, and it reduces the use of IPv4 address. Okay, inside it we have this slash 24, and this is the key. What 24 says that these things are part of prefix of network, and these are the part of host ID, so these are variable. Okay, so for example, only these values can change because these are 32 are total. 32 minus 24 will give you 8, so these are 8 bits which I can change. Okay, so there comes the possibility of address. So the bigger the this number will be, obviously, let's say we have 28 here, so only 4 bits can change. Okay, so how many new address you can generate by changing the last 4 bits? Okay, so 0 0 0 0 2 1 1 1 1. So how many combinations you can get? 2 to the power 4, that is 16 address only you can receive. Okay, so let's say what I'm trying to say is we have 32 total bits. Okay, in these 32, if we fix the rest of 28, because we are saying ours is, let's say, this slash 28, so we are saying fix the 28, so we are left with 4 only, correct? So in this 4, what is my first number? This. What is my last number? This. Okay, so we can only get these many 2 to the power 4 addresses. If we have more, let's say if we go with 24, so we have 8 here, so I can have 2 to the power 8. So this is the idea behind CIDR networking. So let's say our VPC have assume this 10 0 0 0 24. So our subnet will have less than it because it have, let's say, 2 to the power 8. So subnet will have half half, or let's say if you want to create 3 subnet, 4 subnets on you, so you can create 10 10 10 10 26 or 28, but you can't create 20 because VPC don't have that much address that you can assign to 20. Okay, so it will have less than, subnet will have less than the VPC addressage. Okay, so I want to show you here in the console. So let's go to VPC. We will create a new VPC. So we want to create more things. Okay, so let's say our VPC tags, etc., we can keep, but you can see here, if we use 10.0.0 with slash 16, we have 65,000 IP. Why? Because now I can have 32 minus 16, things can change, right? If I say out of those 32, my 16 are only fixed, so half of the panel can change, so we have 2 to the power 16. Okay, so 2 to the power 16 address can change the, and these many IP address you will have. Okay, 65 536. And if I increase it, let's say I increase it to 18, so now I have less IP. 20, I have more or less, as I told you, in the case of 28 we can only have 16 IP. Okay, this is the least we can do in AWS. With 27 we have 32, with 26 we have 64, with 24 we have 2 to the power 8, that is 256. So always try to keep these as maximum as possible, until unless you have less requirement, like in the banking infra we try to create as low as possible, but make sure you leave some bandwidth for the future, so in the future you can create more, because you can't change the CIDR later. This is very very painful later on. Anyways, so in the 16, so now let's create the availability zone that we want. So let's say we want two availability zone. Okay, then we can give the name. So I want to give 2A 2B is fine for me. Okay, US2, US West 2A, US West 2B. Now we want two subnets, and we want two private subnet. Okay, I can give the now the CIDR blocks. As you can see, my host, I mean the my parent have 65,000. So I have to divide it like 20 20, so that 4,444,000 are here. I can't give it to, let's say, 14. Okay, because my original address it have like 262K, but my VPC itself don't have that much. Okay, so no huge. Now net gateway, I want in both availability zone, one per AJ or none. So it's on me. So if I add, you can see net gateway is coming up. VPC endpoint, we want to connect with some resources or not. So I don't want to create. So you can see these type of things have created. We can create by the help of VPC in the console. Okay. Now route table, if I have to create this route table, I want to show you this only. Other things are, I guess, clear to you, like VPC, then subnets, then route table, then network connection, internet gateway, and net gateway, etc. Now, for example, this is one of the VPC I have. Let's go to route tables. In the route table, I have this route table and I have subnet associated without explicitly associated. I have like for these four subnets. You can see the CIDR block. Now you understand what it means because this is the private IP. I told you 172, 198, and 10. These three comes in the private range. 10, 172, 192. So anyone can be according to you what you create. Okay. But routing, let's talk about the route table. So all the destination with this IP address will go to the internet gateway. But if my destination is something like private, like 172, because my subnets are like this only, like 172.31.16.0. So 172.31 and 00. So with this 16 block, so that means these two can change easily. So they will go to local. So again, I'm telling you, if my destination is with this IP, please move to local. If my destination is something else, please move to internet gateway. So this is the idea. And as you know, this IP is already blocked with private. Public can't utilize it, so class will not happen. Okay, but otherwise there is priority also. So now you understand the route table, I think. Okay, now let's come to internet gateway. So like this is the internet gateway attached. So this internet gateway helps our subnet because this IG05. So subnet will connect to internet by the help of this internet gateway IG05. Okay. I think a net gateway will not be there because I don't have private subnet. So net gateway will not be there because we have not created yet, but we will create. So let's go back. Now I think you understand all of these things in quite a detail. We will go through these things by the help of Terraform code. And when we use these practically, will gain more clarity on these concepts. But the idea is you understand what is security group. Security group is at the instance level. Next, NACL are on the subnet level. Route tables are like how internet will move on between these two. So, for example, we have seen here this. I want to show you. So we have seen that if destination is this, please pass this to internet gateway. If destination is internal, all of these IP with 172.10 and 192 are private, so move it to the local target. So I hope you understand in some basic details, not much, and you don't have to be a network engineer because we are in Devops and doing the Django deployment, so we know what we require at this point of time. There are other VPC concepts that we will require as far as our DevOps part is concerned, like VPC peering, VPC endpoint. So we will see as per our requirements. Okay.